welcome to the 8th lecture maybe. क्या कर रहे थे हम लास्ट में प्रैक्टिस कर रहे थे यस सो हमने किस चीज़ की कर लिया इससे पिछले लेक्चर में we did basic probability, assigning basic probabilities, and the last lecture was mostly on say using rules of probability like total probability, Bayes theorem, conditional probabilities, and also working a bit with density functions, PDF, CDF and such. So today we will continue with the density functions, and then we will finish off with expectations. The moments here, mean, variance, covariance. So with that we will have covered practice problems for chapters 1, 2, 3, 4 of the midterm material view. So let's get started with that. So we had done single density functions fx. Now this problem is about joint density function. Joint density function yaad hai? So we started by saying probability A and B. Yeah. So we represented those with functions, two-dimensional functions fx, y. What does this say? If it's a discrete case, it is saying probability x takes the value x and y takes the value y. If it's a continuous case, it just gives you the relative likelihood of x taking value x and y taking value small y. So in this case now you are given the function. It says it's a joint for unit change temperature, proportion of spectrum shift. Okay, some atomic particle produces this. So you're studying some atomic particles, you got this distribution, okay, and now you want to find the marginal densities gx, hy, and the conditional density fy given x. Okay. So if you remember, we said marginal is what? Often we have a joint distribution of two random variables. Now unless they are independent, if they are independent, then the problem is very easy to get their individual distributions. Okay, so real problems ऐसे नहीं होती कि आपके पास you will have fx and fy. Real problems can be maybe you have fx given y and you want fx and y. Maybe you have fy given x and you want something else. Often you will have the joint will be more easily available, and then you want to extract from it the individual. So let's say this is fxy, and from it you want to extract the distributions of the random variable x and the distribution of the random variable y. These two you want to extract from here, and to avoid having to use the subscript, we sometimes just write this as gx, and this one hy. They are exactly the PDF. कोई उसमें फर्क नहीं है definition. Just to emphasize that they are derived from the joint, we sometimes call them marginal, and I've covered this, but just to revise this quickly, we call them marginal density. That's it. So अब ये extract करनी है हमने, याद है कैसे हो सकता है logically? Okay. So what does fxy represent? So fxy represents basically the joint distributions of x and y. What if this is a continuous case? What if I integrate this function over all the possible values of y? फिर क्या होगा? Now that means you have found the probability of the big X taking the value small x, right? Why is that? Because you're saying, okay, what is the uh, basically you are using total probability by assigning all the possible values to y and then seeing, okay, what is this. So it's basically g of x is integral f x y dy, and this is all the possible values of y. Okay, so then you have found what is the probability that f takes the value x, because you have covered all the possibilities for y, so nothing else is left there. तो बहरहाल ये फॉर्मूला है, conceptually we have covered this before, so you can try to see what is happening there. So simply apply this formula, this problem, to extract the density, marginal density of x. What is the marginal density of y? How do we extract that? It's the same thing, but now you integrate over all possible values of x. Yeah. So let's see that. Now, again, we have covered the theory of this, so I'll just go through this practice solving the problem. If you look at this, what should be the range you should apply to y? That's the general case, yeah? But now for the given case, 0 to 1, and what about assigning to x? X की क्या होनी चाहिए? Range. First look here, yeah? What are the possible values of x?
Possible values 0
to
0.
Yeah.
Less than
Right. So x is always between 0 and y. Yes? So whatever value y takes, x will take a value less than that. Right? So x has a range 0 to y. Right? What about y? Now y always stays above x, doesn't it? Yeah. So आप 0 to 1 डालेंगे तो वो that will not represent this situation. Yeah. The general formula says cover over all possible values. That doesn't mean all possible values are minus infinity to infinity. In your problem, can y take a value less than x? नहीं ले सकता. The way you are given this function, it clearly says that y cannot take a value less than x. Y has to be greater than x. So the range for y for any given x is x to 1, right? And for any given, so basically, let's see. Yeah, this is what we wrote. Gx integrate over y, but notice it's x to 1. Why? Because this is the range for what? This is the range for x or y? Dy, yeah? So it's the range for y. And we saw that y was where? It was between x and 1. Yes? So for any value that x will take here, y will be only allowed to take x to 1. So if you integrate from 0 to 1 or minus infinity to 1, you will get the wrong answer. Why? Because these formulas that we write when we write minus infinity to infinity, we are actually saying only all possible values, not really from minus infinity to infinity. Yeah? So with that, it's a simple matter of treating now x as a constant and integrate. Yes, put the limits and you get another function. This function is g of x, which is basically could also represent it like this: the density function of x, the capital X. Yeah. Okay. Now see, the same thing happened in hy. It was from 0 to x had to be between 0 and y. Yes, and that was here. Now notice that we are also restricting the whole thing to be, the x has to be restricted and the y also has to be restricted to 0 and 1. The joint density, conditional density function, we already have the formula. Yes, this is very similar to what we have for probabilities, which was probability A given B equals probability A and B divided by probability of B. Yeah, it's very similar to that. We covered that in the lecture. The conditional density of y given x is the joint divided by the individual of the first or this given variable. Yes, so it makes sense. इसमें कुछ memorize करने वाली बात नहीं है. But now what happens is you have fxy, you have already calculated gx, the two functions you have, just put them here and you can do that. Now there was a part B, they had asked, okay, what is the probability that y takes a value greater than half given that x is 0.25. Now you have this function, yeah, basically here, so you can find the area under that region, yes, or the volume there, sorry, and calculate it. Okay, so it's a matter of just using the formulas you have and also applying the understanding that we have developed in the theory lectures. So this is another problem. Select and find probability x1 is less than 2, x2 is between 1 and 3, and x3 is greater than 2. So I'll let you read the question and then tell me if it makes sense to you. करना क्या है इसमें? What are you given? The PDF, yes. The probability density function. Is this a continuous case or a discrete case? Continuous, because when they say x greater than 0, they don't say anything about being discrete values, right? So it goes कोई भी value ना करे. So it's a continuous case, yeah. And we know, of course, this is shelf life, so it's also time, so it's continuous. Okay, then what? x1, x2, x3 represent shelf lives of 3 of these containers, food containers, and there is some key information in here. They are selected independently. So the shelf lives of these will be independent of each other. तो इसमें आपस में dependency नहीं है, yeah? Then you're asked to find what's the probability x1 is less than 2, x2 is less than 3, and x3 is less than greater than 2. कैसे करेंगे? Firstly, what does this remind you of? Is it conditional, single, joint? What does this look like? Conditional, but there are nothing given. All the variables, just range is told. You're not told x3 is equal to something, or given that x3 is greater than 2. They're saying probability that each of these takes these values. So basically, we have already seen for the case of two random variables fxy, that is the joint distribution or density, and if they happen to be independent, it can be separated like this that we talked about, right? Otherwise it cannot be separated. Otherwise you have to use conditional formulation or something else. Only if x and y are independent, then, and we have covered the concept of independence in the theory lectures. You can watch the video again. but essentially once you're told that random variables are independent, you can directly use this result. Okay, so now they are talking about how many random variables are they talking about? 3. 3 container है, तो हर container की shelf life, each container shelf life is one random variable. So there are 3 random variables. Essentially this can simply be extended if they happen to be independent. If 3 random variables happen to be independent, then it's simply like this. Okay, even 4 or whenever you like. Okay, so the problem becomes simpler. So the joint density of these guys, basically fx1, x2, x3, whatever it is basically fx1, fx2, fx3, and this we are able to write because of this given information. If this weren't given, we are stuck. At least with this information, you will not be able to solve. Yeah, but now since this information is given, you can use it. Now what's the density function for the shelf life of the first container? तीनों का same ही दिया हुआ है, and the function is same. So basically you will have this function here multiplied by the same function here and the same function here, but with what? 3 different random variables. This will be with x1, for the other one you put x2. Function की shape same है, लेकिन जो value है, जो random जो variable है वो different है, x1, x2, x3. Yeah, so you put that here. Now the question is, how do we find this? This is a probability in a range में, yes. So we have seen that, like for 2 random variables, if you want the probability of these, what is the probability that x takes the value less than let's say a, and y takes the value less than b? We have covered this in theory. It's basically the area under this, or volume, is minus infinity to b and minus infinity to a. Okay, so basically you integrate this function over whatever range you have. So if you had 2 variables, you did double integral. So if you have 3 variables, you will do triple integral. So basically then what you're looking for, this probability is integral f x1, x2, x3, dx1, dx2, dx3, and now you can start from the inner one. What's the range for x1? Minus infinity to 2. Where is minus infinity coming from? They are saying x1 is less than 2. Yes, but now we can make this even more simpler in our case. Does it have to be minus infinity, or it can be something else if you look at it carefully at the function? X is greater than 0. So we don't need the general thing. We can make this range even smaller for our case. Yes. So yes, it has to be less than 2, but we know it's always greater than 0. So basically this function is saying, what's the probability that x1 is between 0 and 2? Yes, because we already know it cannot be less than 0. So its range is now 0 to 2. What about x2? What range should I put here from that problem? Range 1 to 3. Yes, so that makes sense. And then x3 is, think about it. What they're saying? x3 is what? Greater than 2. So range क्या होगी फिर? 2 to infinity. Yes. And why we cannot stop from infinity? We don't have any condition saying it's less than 10, right? So we have to integrate till infinity. Yeah. So 2 to and then let's stop that. So it has to be 2 to infinity. Yeah. Now it may look complicated, but it's basically exponential function है ये 3 exponentials. When you multiply, it will be e minus x1 plus or minus x2 minus x3, right? So even if you know basic calculus, usually I also give some formulas in the exam if they are needed, so don't do it too much, but you should at least have an idea of how to get things started, yeah, for integration. So let's see if we got it right. Yeah, there you have it. Yeah. So you always need to identify the problem. What is the problem talking about? So when the problem asks you for this probability, you should immediately realize this is a joint probability thing. Joint for 3 cases like this. Now this would be very hard to calculate based on the information, except that they told us they are independent. As soon as you know they are independent, the same holds as I keep repeating just because it's very important. Probability of A and B is not equal to probability A times probability B. It's not. Only one case where it is, which is when you know that A and B are independent. Okay, then you can use this. Otherwise, you have to use maybe conditional probability formula or something else. So same applies to density functions. For without knowledge of independence, you can never claim this thing. Okay, fxy is it equal to fxy? No. Only when you know it. But once you know it's independent, things become very easy because then they are separable. This is what we call separable. Yeah. So when they become separable, once they are separable, each has its own function. Just put that here as we did. Now you're looking for ranges. Yes. So ranges in continuous case, how do we find them? By integration. In discrete case, how do we find them? By summation. Yes. So it's a matter of simple integration to get the solution here. Okay, now we are on to moments. Yeah, so it's already going to expected value. Yeah, rather mean, variance, covariance. Yes, so we have done the theory in detail. Now we are doing the practice problem. So they are asking to find the expected value of the number of good components in this sample. So what's the problem? There is a lot set, yeah, containing 7 components, and it's sampled by a quality inspector. The lot contains 4 good components and 3 defective ones. Sample of 3 is taken by the inspector. So firstly, is this a what's the random variable here? Let's say I want to define the random variable x. Yes, what's that random variable? It's what? So the random variable x, yeah, क्या होगा इस केस में?
Sir, for t components, total we have 7 components.
वो तो हो गया ना. How shall I write x? So like when I roll a die, I say x is the number that shows on the die. 1, 2, 3, 4, 5, 6, right? So what should x be here in this problem? 3.
Sample space 7.
पहले तो आप इसका ये बताएंगे ना, definition बताएंगे. X is find the expected value of the number of good components, right? So x is number of good components. This is your random variable, right? Number of good components. कितने में से? 3 में से. So 3 लिया ना? the inspector took 3 out of those randomly. Yeah. So अब x की values क्या है, possible values क्या है? So the inspector picked from a lot of 7, he picked 3 samples randomly. Yes. So how many of them can be good?
4.
No, from the 3 he took. So 3 निकाले. Right. So the inspector took.
उसने जो 3 निकाले वो total components में से
हाँ, 7 में से निकाले. उसके सामने 7 पड़े हैं. He had 7 in front and he took 3. Yes. Now we are saying how many of them are good. Right? That's our random variable. Yeah. So how many can be good? Defective कितने हो सकते हैं? 3.
तीनों ही हो सकते
3 हो सकते हैं. Right. और good कितने हो सकते हैं?
हैं 3 हो सकते हैं
और क्या हो सकता है?
या तो possible combinations बने
नहीं, इसमें इस केस में x की वैल्यूज करता है. कॉम्बिनेशन बाद में आएगा ना. You take three samples, right? So none of them can be defective.
Yeah.
Or sorry, in this case they are looking for good components. Yeah. So it could be that none of them is good, one of them is good, 2 of them are good, or all 3 of them are good. X की values फिर क्या होगी? 0, 1, 2, 3.
but we're just talking about the good components, right?
Yeah, yeah.
So we cannot have 1 or 2 good components.
Why?
Then we'll have to have the defective ones. If we have 2 good components, the third component has to be a defective one.
Yeah, that's fine. What I'm saying is, what's this random variable? It's saying number of good components, right? If you read this, what values can you put here? समझ रहे? इसका अभी हमने कैलकुलेशन शुरू नहीं किया है. It's just saying what this random variable values this random variable will have. So x can be the number of good components. There are 7 here samples. Yes. Out of them, how many defective? 3 defective and 4 are good. Yeah. Now the inspector from here, without knowing, takes how many? 3. Yeah. This random variable, we know he takes 3. This is not a random variable. What we want to see, okay, how many of these 3 are good? Yes. So what's the sample space? You know there can be all 3 can be good, 2 can be good, 1 can be good, 0. So from our perspective, the random variable x, why did I define it like this? Because they said it, expected value of the number of good components, right? So we want to find the mean of the number of good components. So the random variable has to be this thing. Yes. Now is this a discrete case or a continuous case? Is random variable x discrete or continuous? Discrete. It can only take 4 values, 0, 1, 2, 3. Yes. So how do we write the expectation of a discrete case? The mean value of a discrete case, what was the formula? So if it can take xi value, then you do fxi over all values of xi, right? And in your case, xi are 1, 2, 3, 4. Yes, 4 possible values. So to find expectation now, what's left? In our case, this formula will be, so I'm just spelling it out. This is x1, let's say this is x2, this is x3, and this is small x, okay, let's make it x4. So we have x1 times fx1 plus x2 times fx2 plus so on, x3 times fx3 plus x4 times fx4. That is the expected value. Yeah. So now the expected value, do we have this x1? Do we have that value?
Yeah.
Yes, we have it. do we have what it needs to multiply with? fx1?
Is it
No. What would fx1 represent in probability? This is a discrete case, yeah? What is this representing? Can you tell me?
probability of
X?
of good components in X?
Yeah, so it's x taking the value x1. Yeah, so to solve this thing, you need these densities or these distribution values. In this case, this is discrete, so you need the distribution values. Now, for the discrete case, fx1 is probability x equals x1. Your x1 is 0, right? So that's one value you want to find. Then you also want to find probability x takes the value 1. Then probability x takes the value 2. Now let's do one of them. What's the probability that all three of them are defective? That would be your fx3. Yes, probability, or in this case actually x4, probability x equals 3. All of your values are all the samples you took are defective. Yeah. So how do you calculate that from the given information? Now the combinations will come in. Yes. So how do we do it from the sets? Basically, you will see, okay, what are the total number of ways you can select 3 items from? कितने में से ले रहे हैं आप? Total 7. Yeah. So number of ways you can select 3 items out of 7. Yeah. And they are they're not distinguishable, so it's a case of combination, not permutation. Yeah. So 3 out of 7. Now, how many ways are there? If you are saying all 3 are good, then you are saying that you picked all good ones. Yeah. So how many ways can you pick 3 good from 4 and 0 good from the 3 bad ones? We did something like this before also. Yeah. So with that you can find the probability of each of these outcomes. Yeah. So number of ways you can select 3 out of 7. Now if you are saying all 3 were good, yes, then you are saying that I ended up choosing the 3 good ones out of the 4 good ones, and I chose no bad one out of the 3 bad ones. That's the only way you get 3 good if you pick 3. Yeah. So similarly, what would you change for probability x equals 2? What would change here? Will the denominator change? No, because that's the total ways you can take. What will change is the numerator. Yes. Then you will say that I take 2 good ones out of 4 and how many bad ones out of 3? 3 से दिया ना आपने, तो 2 good हैं तो 1 bad होना ही है, right? So that has to be 1 out of 3. Make sense? So that is how. Now notice sometimes the problems combine your entire knowledge. ये problem, it's actually about mean value. Yeah, but to solve it, you need chapter 2, right? Basic probability assignment. Okay, so they are not separable. कई cases में होते हैं separate, but mostly they require your entire knowledge. So be very careful with that. So they have written a general formula. If you want, you can write it, but you can also go for a. Remember we did for 3. What did we have? 3 7 3 4 0 3. Yes. So the general formula will. They just made up a general formula to help themselves. But then after that, it's simply a matter of possible values time probability of or the PDF of that value. Possible value times the probability of that value. So that will give you the mean value. That example was for a discrete case. Yeah. Now let's look at a continuous case. Let x be the random variable that denotes the life in hours of a certain electronic device. The PDF is given here. Find the expected life of this type of device. Yeah. So what was the definition of the expected value for continuous case? अभी discrete के लिखी था मैंने summation xi fxi. Yes. So what was this for continuous case? क्या था? Summation replaced by discrete से continuous में जब जाते हैं summation is always replaced by continuous sum, which is integral. Right? So it is x fx dx minus infinity to or over all possible values of x. Yes. So can you tell me how we will write it for this case? Now you are what are you given? You are given fx. Yes. So can you put that here now? Expected value of x is x times fx, which is 20,000 divided by x cube. What about the range? Can somebody help me with the range? Dx. The general formulas always say minus infinity to infinity or minus infinity to a. What they mean is over the possible values in this range. This is saying all the possible values. Yeah. So should we solve this with minus infinity to infinity or something else? In our case, 100 to infinity. Yes. Why is that? Because all the possible values, the way you are given the function, they are saying x cannot be less than 100. Yes. So no point. In fact, you will get the wrong answer if you include minus infinity to 100 also. So you have to exclude that part. Okay. So it's almost like saying, okay, we started with minus infinity to infinity, but then we realized that minus infinity to 100 had a density of 0, right? So this part only applies to 100 to infinity. Yeah? So the rest is removed. Now it's simply a matter of integration. Yes. So integrate this thing and put the limits, and you will get So on average you expect this product to last 200 hours. That is the expected value. Okay. Let's see now another problem.
Can we go back to
Yeah. It's in your book.
before that?
Basically this is what you need to understand. Yeah. So you always need to see what the problem is about. What do we know about this problem or this topic? So this problem was clearly about expected value. We know for continuous case that this is what the expected value is. Always. Yes. And for discrete cases it's summations. Yeah. It's always the case. That is where integral comes from. Continuous infinitesimally small चीज़ों को sum करते जाते हैं. Limiting case में तो you get the integral. Yeah. So that is simple jump from there. ठीक है? Okay. So now let's look at another problem. This is saying you are given the cars passing between so and so. Amount of money in dollars paid to the attendant by the manager. कार वॉश है, उसमें कार्स आती हैं, ठीक है. 4 and 5 p.m. on a sunny day, Friday has the following property. What is it saying? That the number of cars x. Is it a discrete case or a continuous case? Discrete है ना. कितनी कार्स आ सकती हैं based on their statistic जो उन्होंने collect किया है. Between 4 and 5 यानी 1 घंटे में sunny Friday को 4 गाड़ियाँ आ सकती हैं कार वॉश में, 5, 6, 7, 8, 9. You can experience that it's not based on any science, okay? These kind of things are based on past data. Yeah. So now their data says that the chances of 4 cars coming are 1/2. तो वैसे most likely क्या है इसमें ज़्यादा 6 और 7 आती हैं 1/4, yeah, between 6 and 7 cars come. Some days, bad Fridays, only 4 come, and some good Fridays. Actually, these are not good either. Basically, so these are not too good for business. This is good, yeah. Actually, this is also good, but the probability is low. Right. So gx क्या है? X is the number of cars coming for the car wash in that 1 hour. Yes. Gx क्या है? This is the amount you pay to the attendant in dollars. So what is it saying? They are saying अगर 4 cars आई तो उसको कितने पैसे मिलेंगे? Dollars. $7 मिलेंगे, right? If there are 5 cars coming, how many? 9. Now this g of x, if I want to call it y, is it a random variable or not? जो उसको पैसे मिलने हैं, let's call that y. Yeah? Is it a random variable or not? The attendant getting $7, $9, different है ना values. तो वो values जो उस दिन उसको पैसे मिलेंगे even Friday पे 1 घंटे के, it is a random variable. Why? Because it is dependent on a random happening. This random variable, which is again dependent on something random, so it is a random variable. Yes. Now, what are the possible values of that? We could see that, but here basically, what do we know about a function of a random variable? So if you remember, I covered this thing that expectation. By the way, they are asking us for what? Can you tell me? Find the attendance expected earnings. इसको अगर लिखना हो mathematically तो कैसे लिखेंगे? What are they asking for? Firstly, they are expected earning. Yes. If I say this is y, then they are asking for EY, isn't it? Yeah. What is the expected value or the expected earning? और earning को हमने कह दिया y. Yes. And we have a formula for that. So this is what we are asked for. Now before trying to solve this, कैसे वैसे try करें, कैसे solve करेंगे इसको? I want to see how will you start? फिर क्या करेंगे? 4 cars की earning we saw it was $7 and so on. Okay, so you got for each of those, fine. फिर क्या करेंगे इसका?
We multiply it by the probability of that.
So let's say you found for 4 cars. So how much was it? 7. Yes, and then for 5 cars it's 9. Yes, 6 cars it's 11. इसी तरह चलेगा. 7 and 9. And now what are you saying? So you will take this, multiply this with what?
Probability of
this happening?
Of the expectance of x small x.
Right. So क्या होगी probability इसकी?
1 over 2.
1 over 12. Why is the probability of him earning $7 1 over 12? Because that is the probability of 4 cars showing up. So उतने ही वो उस लिहाज से earn करेगा. So you're right. That is, you can, what you did was you went back to the definition. Yes. So that is what I want you to cover. If you have, as I've been saying, for each chapter you should have a very brief 1-page summary of the key results or concepts. If you have that for the chapter 4, you will definitely in there have this thing which I have covered, that ax plus by, remember I said expectation is linear operator, so it can always be written as AEX plus BEY. That's one thing. Then we also said, we showed that E of the function of a random variable can also be given, if it is discrete, it can be given as g of x times small fx, this is I, over all values of xi. So you will have both of these in your sheet, because these are very key results. What you just did, you know what you did, you used this one. See, you said we will replace 4 by 7, that is g of x, that's how you got it, right? And then multiplied by the original 4's probability, that's what you did. Yeah? Plus you will replace so this is multiplied, plus you will replace 5 by g of 5. G of 5 is 9, multiplied by the probability of 5, which was again 1 over 12. So essentially, yes. So now either you do it directly intuitively or you use this thing, but there is another way, a faster way. If you have collected all the information correctly, you will realize that if I have said that expectation is a linear operator, yes, so then expected value of 2x minus 1 should be what? Based on the upper form. Both approaches are, all three approaches are correct. Okay, but I just want to cover the third one also. What does the formula say? If it is a linear operator, how can I expand this? Can we expand this?
Would be the same.
2ex minus e of, what is the expected value of a constant? हमने किया था, the constant itself, right? So minus 1. Yeah. So if you do it like this, then you don't even need to calculate sine 7, 9, 11. You know, because what happened just now? Now you have rewritten the expected value of y in terms of the expected value of x. Yes? And the expected value of x you can directly do from here. 4 times this, plus 5 times this, plus 6 times this, plus do that. Whatever value you get, put that here, multiply by 2 minus 1, and you get the same answer. Yeah.
But here we're talking about his total expected value.
So
all the variables. We have to use all the variables in order.
yeah, we will use all the values to get e of x.
So it makes the same.
Yeah, it will give the same answer, but you won't be calculating this part for
Sure.
4, 5. अभी किया ना हमने 7, 9. लेकिन if you use this approach, आपको use नहीं करना नहीं पड़ेगा, right? Both are correct, but I think this one is more efficient. Okay, it's not, doesn't make a huge difference now. अगर data बड़ा होता जाता है, then it becomes complicated. Right. So always remember this. Once you have written what the problem is asking you, then try to recall or see what do we know about this topic. Yeah. Collect that somewhere and use that to practice, and then it will become second nature for using those approaches. So yeah, this was the one we used now, the first approach, but the second can also work fine. Okay. So there are two companies used for official business purposes on any given workday. Probability distribution for company A is this, company B is this. Show that the variance of the PDF for company B is greater than that for company A. It's a very simple problem of finding the variances. Yes. So you are given these things. Are these discrete cases or continuous? Discrete. Yes. Now, what is the problem about variance? Yes. So in your single sheet, there should be key information about variance. Yes. What do we know about variance? तो कुछ याद है क्या होती है variance? That's the thing. If you have that sheet when you're practicing, this R thing, or we know this, will be out. Yeah, and you can't go through 200 pages of the book's chapter every time. Yeah, so that helps a lot. आपकी एक chapter की एक sheet बनी चाहिए बस. Key information there. Don't repeat long sentences. Yeah, and don't just put the formulas. वो भी काफी नहीं. The whatever formula is needed, with whatever interpretation is needed. Brief one. This is what it's saying. This is what it's saying. This is how you use it. This is where you use it. And then when you're practicing, have that handy. With time, slowly put that away, and then practice some more. Easier later. लेकिन अगर आप just take a problem and say, yeah, chapter 4 में कुछ था इस बारे में, yeah, you start. You just keep going between book and lectures. कभी वीडियो सुनेंगे, कभी लेक्चर खोलेंगे, किताब खोलेंगे, कभी problem solve में time while yeah. So collect the information. So anyway, this is a discrete case, and what do we know about variance? क्या पता है हमें variance के बारे में? How did we define it? Definition is usually the degree of spread. Yes, good. And in this case, now the variance of a random variable x was the expected value of x minus mu x square. Right? On average, how much does it deviate from its mean in the square sense? You will do interpretation on it. Detail, we did that. So we know this, but is this the only thing we know? Well, we additionally we know that we did that, and we saw that actually you can even write it like this, expand it, and it leads you to this and then another interpretation. Now we also know that if this is the discrete case, we can write it as a sum of the density function, right? So then somebody helps me write this here. This is additional information that we know, right? Since it's a discrete case, I can write it as a summation. So क्या होगा? We are talking about the expected value of a function of x. Yes. So that means we can simply replace it by that function times fx I over all values of xi. Now this is your gx. Yeah, किया हुआ ना हमने? So that's why I always ask you at the start, is it discrete or continuous? Because I want to decide if it's a summation or an integral. अगर वो आप establish नहीं करेंगे और अंदर blindly एक लगा देंगे तो मसला है, yeah. So now it's up to you which one seems more feasible. In this problem आपके ख्याल से क्या कौन सा बेहतर है? Find हमने यही करना है दोनों के लिए, right? This one? Okay. So do you have e of x square? Firstly, आपको mean x तो निकालना है, right? All of them require that. So can you find mean of x? कैसे निकालें? For this case, what's the mean? Mu x is basically a symbol for ex, right? What is that mean? Summation xi fxi, isn't it? Yes. So do you have xi's? Yes, 1, 2, 3. Do you have the density or the likelihood of each one? Yes, I do. This time this plus this time this plus this times this. That gives you mu of x. So now either you use this or that, at least you have mu x. Yes. For me it seems easier to go here, because what I would do then is put mu of x, whatever mean you find here. This is saying take the first value. I'll take 1, put that here, 1 minus the mean square times the likelihood of that, plus take the second value minus mean, square it, times this thing, and you could do like this also, but then you will have to first calculate this e of x square, which is not too hard either. You know what will be e of x square? It will be summation xi square fxi, isn't it? Because the general formula is that e of g of x for the discrete case is summation g of xi f of xi over all xi. Yeah, the general formula. So either you use this g of x or you use this g of x, it's fine. Lekin I feel this is the fastest way, but you will still get the right answer and बहुत ज़्यादा time नहीं लगेगा. So what I'm emphasizing here is not a particular problem. I'm emphasizing here the approach to solving problems. You should listen to lectures or read the book, and while you're doing it, for each section, write on the side, on a paper or on the side of the book, a very brief one line for one paragraph or even one page, 1 or 2 lines or formulas that are the crux. Yeah. Then after you've gone through the chapter, collect those lines on one page. Yes. Now you have the whole extract of the chapter. Now take that page, take the sample problem, read the problem, and then of course when you're practicing, take problems from that chapter. कहीं और से लेंगे तो फिर वो page तो काम नहीं आएगा. तो towards the mid and the final you should know everything, then all the pages will be used. So look at that problem, see what it's asking for, and then refer to your page. What does my page say about this thing? What does it say about variance? What does it say about conditional distribution or conditional probability? And then see, okay, how I can try to solve it. Yeah, these are the 3 things I know about variance. Which one seems most relevant here? Try that, maybe use that stuff. And if you see again and again that the solution is using some concept or some result that is not in your sheet, then you miss something when you read the first time. Yeah, so include that, add that to your sheet, update your sheet. Yeah, so that way after a while you will have all the key information. एक बात आप the same things keep on repeating. आप कोई नई research तो नहीं कराते आपसे course. It is not a thesis. Yes, कभी कोई हल्का सा trick होता है, that is just what you see, your intuition. But not every problem is like that. So if you actually do like this, you, after a while you will know all the tricks of the trade. सब आपको आ जाएंगे, and you will be in a better position to really good well in the exam. Yeah, so I wrote that here. जो मैंने लिखा है, we know this about discrete case, about variance. Yeah, variance का ये symbol we use. Almost all people in probability use this. Mean के लिए use करते हैं mu, variance के लिए sigma square. Okay, so I already mentioned this. So this these are in your book also. It's fine. लिख रहा आपने? But you know this. Done? Okay. So as I said, this is possible to do. It's not a big deal. Now let's go to another problem. It says the weekly demand for a drinking water product in thousands of liters from a local chain of efficiency stores is a continuous random variable X. So they already say it's a continuous random variable. Having the probability density, listen, find the mean and variance of X. This I will let you do quickly. The mean निकालने से. Again, what's the approach? First, identify what you are given, what the problem is about. This is very clear what the problem is about. किसके बारे में ये problem? Mean and variance. Then it's not about conditional probability, is it? So, in this case, mean and variance. Are you given the density function? Yes. So what's the mean? क्या formula है इसका? What do we know about the mean? Right? We know it's a location parameter, it's the center of mass, it's all that. But in this case, कौन सा applicable हो जाएगा फिर? The definition. So just help me see what is E of x. क्या है? What do we know about E of x?
Integral of x to
Integral. Why integral? Yes. X over all possible values of x. Right? So, do we have fx? We do.
sir, limits
हाँ वो तो ये तो जनरल लिखा है ना अभी. That's why I say all possible values of x. So now we will start adding things. Do we have fx? Yes. Yes. Where does that fx apply? It's 0 everywhere except for here. So this area should now be reduced to 1 to 2 x fx dx. So it's a simple matter of integrating this thing, x times 2x minus 1. Yeah, so we will do that. What do we know about variance? Well, we know variance is variance of x, as we have already written, but we can say it's the x minus mean of x squared fx dx, and in this case again it's 1 to 2, and you just found the mean in the first part, right? Put that here and then solve the integral. So we are not repeating the core concepts again and again, those we covered in the theory. Often this kind of problem are more rigorous. It's like formulas, mathematics, that thing. But of course, both should be very clear to you, how to apply the formulas and how to interpret them, because that will help. So, yes, 1 to 2, twice x minus 1, integrate, put the limits. Similarly, here what they did was they have used the other approach of ex squared. So remember, the both formulas should work, it's not a problem, but the solution has used variance of x is also, it can be written as ex squared minus mu x squared. Okay, so either way it will work fine. So first you calculate E of x square, yeah, and then put that here. You already had the mean, square that, and now you have the E of x square. That's one way, but you are perfectly fine if you want to do it with, as I said, this approach, x minus mu of x square fx dx. Okay. In this case, arguably this approach is better because it's a simpler integral compared to this one. It's slightly simpler, कोई इतना बड़ा मसला नहीं है. Okay. So all of this is about moments that we are covering. Yes, mean, variance, covariance, right? So now, what's the problem saying? fraction of X male runners and Y female runners complete marathon races are described by joint. So जितने males they participate in a marathon, what fraction of them complete the race? Let's say maybe 80% of them complete the race. That's the fraction, 0.8. Yeah. And what fraction of females in the race? So if there are whatever number is there, if 50%, 60% of the females complete the race, then they are, that is 0.5 the fraction. Is it a case of continuous or discrete random? Continuous. Yes. So if you were talking about number of males and females, it will be discrete. But when they are talking about fraction, fractions can be 0.8, 1, 2, 3, whatever. Yeah. So it's a continuous case. The density function says this. By the way, what is it already telling you? Interestingly, that you expect more fraction of males are expected to complete the marathon than females. Yes, because X is always determined by, in this case. Yeah. So you are given the density function. What's the question about? This is, you are given the joint density. Yes, it's about covariance. Then back to your sheet. There should be some 2 or 3 lines about covariance. Yeah, क्या होती है उसका key result क्या है, all that. So अभी तो आप पास नहीं है, लेकिन please make it very quickly and start practicing with that. So I'll show you. I'll collect it here. This is what your sheet should be showing you. आपके should be handwritten. Copy you print ना करें. This should be your notes. Yeah? Should be saying, okay, this is what I know about covariance. And it should even say somewhere that covariance is the degree of linear statistical relation. Yes. अब इस जुमले का मतलब क्या है? There is a long lecture on that. Yes. So you should have listened to that and you can revise that. So it's not just about formulas. Also write the key interpretation from time to time. Right. So the expected value, the covariance of X and Y is basically discrete and continuous. The definition is the same, but that when X deviates from its mean, does Y also deviate from its mean on average? How much does that happen? For the discrete case, this results in double summation. For the continuous case, it results in double integral. Okay, and we also have a simpler or simplified version of this. Yeah? Just like we had for variance, we have for covariance, EX. So you will decide what is useful, what is applicable. Yeah? Then we also have other information. Maybe it's not used in this problem, but your sheet should have that key information. That's why I put this here. Let X and Y be two if X and Y are independent, then their expectation is separable. This thing shows up again and again. Okay, if events A and B are independent, then P A and B is P A times P B. The probability is separable. Otherwise, no. This does not hold in general. If A and B are independent, then no. Similarly, in densities, it's if they are independent, then fxy is fx times fy. Yeah. To distinguish the functions, I am putting another subscript here, f capital X X. The same thing then continues to moments. Yeah. Module 1, module 2 of the course, and module 3 of the course. Yeah. Probabilities are separable if they are independent. If they are independent, the density functions are separable, and if they are independent, the expectations are separable. So EXY is EX times EY. Otherwise, it's not. Yeah. EX plus Y is always EX plus EY because expectation is linear. It can be proven. No need to see if they are independent or not. Okay, this always holds. Yeah, but the product, no, it doesn't hold unless they are independent. Okay, so exy is ex times ey. And also we say that two random variables, if they are two, then what happens to their covariance? If they are independent, their covariance becomes 0. Yeah. Now, based on this, what information you have, can you prove the last line quickly? Last statement, can you prove it? You have all the information you need on this sheet. The last line is saying if x and y are independent, their covariance is 0. Okay, this is a very strong assertion. It's very useful. Can you prove it from above? सही है, लेकिन यहाँ से कुछ बताएं ना क्या करेंगे यूज?
The expectance of xy is the mean of xy.
Yes, if they are independent, you can use this result, right? If you can use this result, you are saying it can be separated into ex, ey. But what is ex? Mu x. What is ey? Mu y. Mu x, mu y minus mu x, mu y is 0. Whatever the value was, they are 0. Yeah. So yes, it can be proven very easily. Anyway, once proven, you should know this result. Yes, clear? Now, in this problem, there is no mention of independence or anything, so we will not use this part, but we will use some of these parts. Yeah. So let's see. Yeah. Here we are. Find the covariance of x and y. So to find the covariance of x and y, there are different ways. In this case, we have decided to go for this formula. This formula was in your list. You knew it, yes? Now, you know that to get mu x and mu y, you need to find basically the mu x and mu y. So, to get mu x, you know its definition is ex, x fx, dx. The problem here is I don't have fx. The distribution of what's going on? Yeah. The x alone. To get mu x, which is e of x, I need x fx dx, don't I? I don't need fxy. Yeah, and it doesn't say they are separables, independent, so I cannot use that. So I need to extract from it the density function of x, and when we extract from the distribution joint, we remember we called it the marginal, right? And our pehla problem was on that. Yeah, we did that. So just review that, how to extract the marginal from the joint. Now this is what is done here. You first get the marginal distribution of x, the marginal of y. Why was that done? Because there is no way to find mean of x without that. So your sheet of chapter 4 will already have above the variance part, it will have something about the mean part, right? So then you should be able to use that here, and your previous sheet from PDF should have the marginal. हमने cover की थी ना, marginal, posterior, all that. So that should have it, and now you start solving the problem based on that knowledge. So basically, find the mean, find the marginals. Why do you need the marginals? Because you need them in the mean. Why do you need the mean? Because the covariance needs the mean. So once you have the means, put them here. Exy is basically again the expected value of xy is gxy dx fx y dx dy. Yeah. So let's see, hopefully this is the last problem. Yeah, let's make it the last one. So what's this saying? The weekly demand for a certain drink in thousands of liters at a chain of convenience stores is continuous random variable. When x has the density function, so and so. Find the expected value of the weekly demand for the drink. What's the problem about? Mean. Expected value, yeah? Again, go back to your knowledge sheet. What do we know about the mean? Yeah? So we have repeated that many times today. So you know that the mean is, well, is it a continuous case or a discrete case? It is a continuous case, so in that case we know that the mean is, you should know that it is x fx dx over all possible values of x. That's one definition, right? Yeah, that's the mean of x. But are we asked for the mean of x? No, we are asked for the demand, which they say is g of x. Let's call that y. So we have been asked for e of y, not e of x, right? So then you should remember, okay, in your sheet you should have that the expected value of g of x, a function of x, we just did that before also, is what? For the continuous case, it is g of x fx dx. Basically you replace x by gx, that's all. Yeah. So your formula sheet or your summary sheet should have this. I don't call it formula sheet because it should also have some interpretations in it. Yeah. So minus infinity to infinity gx fx. Now in your case, which case are we dealing with? They asked for the demand which is not x, is g of x, if you read it carefully. So they asked for, and it often helps to call this y and then see, okay, what do I need? So if we are looking for e of y, we are looking for e of g of x. Now your summary sheet should tell you that the expected value of a function of a random variable can be calculated like this. That's one way. But then your formula sheet, your summary sheet should also tell you what I've been repeating many times. What is that? That the expectation operator is linear. Yeah. So it's a e x plus b e y, or this is one case, but linear means it's generally separable. The additions can be separated. If you remember that also, if you have that in your summary sheet, you will know that there is another way to do this e of g of x now. This is one way. Yes, this is one way, but then there is another way. If your summary sheet is there, what will it help you see the possible tools available to you? Then what you can do is choose the best one. Yeah. So when you're practicing, you will not always choose the best one. You start with the wrong, not the wrong one, hopefully, but not the most efficient one. Yeah. But let's see. It's e of x squared plus x minus 2. If you really understand what I mean by that the expectation operator is linear, you will know that you can actually write this as what? E of x squared plus e of x minus e of 2, which is 2. The mean of a constant is constant, the variance of a constant is 0. Yeah, we did that in detail. So either do it like this now, yeah, or do it like this. Then you have to find e of x and e of x squared and subtract 2 from that. Both ways are fine. In this case, it seems to me that, let's see which one I would use. If I had to put 2x, by the way, the limits of course they are clear to you by now. When you do any of these will be 1 to 2. Yeah, that's what you're given here. Okay, so I would probably go for, let's see, 2x minus 1, and I have to put that there. Yeah, I think this seems a bit more complicated to me, so I would probably go for this approach. Okay, because otherwise I'll have to replace x. This thing will be here squared plus this thing will be here, and so it will become very large for me. So this is kind of separates the integrals I can solve. Both ways are correct, and let's see. Yeah, the linear thing and the variance being like that. So yeah, your book has also used the second method that I was saying, talking about that you can separate this to ex squared. This, here it is, yes, plus ex, here it is, minus 2. So ex squared plus ex minus 2. So they are simpler integrals basically. But to know this, where to start, what are the possible approaches I can use, those summary sheets should be there. And once you get used to using them, then it becomes, you don't even have to memorize these things, they're very straightforward. Yeah. Okay, that's it for today. Thank you so much. Next lecture we will start our, actually we will come back to the second module. Okay, what was the second module? Collecting probabilities in distribution functions, right? So in the next lecture we will come back to that and talk about some common distribution functions. Okay, we didn't talk about that before. We just defined them and talked about their properties, what they mean. But now, what are common distribution functions? You have seen one already, uniform, all things having equal probability, and there is the Gaussian. Yes, but what others are there? Yeah. So basically, we would like to talk about what these density functions look like in most cases. Yeah. So that helps us classify. जैसे आप डिटर्मिनिस्टिक मैथ में पढ़ते हैं ना, आप you read about nonlinear functions. Yes, but you leave it there? No. Then you read about or study common nonlinear functions. कौन से हैं normally जो आपके पढ़ाए जाते हैं? Quadratic. What else? Linear तो हो गया ना. Let's say we say this telling you about distribution functions is saying, like in the deterministic math, saying nonlinear functions. Okay, but then what are the common nonlinear functions? This is what we will do next for probability. What are the common distribution functions? But nonlinear functions that you normally work with, exponential, quadratic, it is a part of that, logarithmic, or trigonometric, yes, transcendental functions, all that. So you study cases of that. Similarly here, we will study cases of what these look like. Okay, and we will see that next time.